Okay, so find your guided notes for applications of linear equations in two variables. What I'm going to do is create two videos on this. One of them will be to set up all the problems, and then the next one will be to work them out. Okay, so the first video is just getting everything all set up. Okay, so what we've got here are word problems that will turn into two. We can translate the words into math equations, and we'll have two equations that will create a system of equations, and then we'll go on and we'll solve it using the techniques we learned in sections 4.2 and 4.3. Okay, so what I'm going to do now is focus on getting everything set up. Okay, that's usually the biggest struggle. All right, so what you do first is you just do a quick read of the problem. Sum of two numbers is 64. The smaller one is 6 less than the larger. What are the numbers? Okay. So I hear them referring to a smaller and a larger number, and our job is to find the numbers. So this is a very important first step where you tell yourself what you're letting your variable stand for. So I'm going to let x be the smaller number. You should write this. And y be the larger one. You could have done it either way, but you're just telling yourself what you did. All right, now notice we have two sentences on this problem. So each sentence, this first sentence, okay, and then this second sentence are going to get translated, and that'll give us two equations with two variables. And then we'll wind up using the techniques like substitution or elimination to solve them. Okay. All right, so the first equation I'm going to get for the first sentence. It says the sum of two numbers is 64. So see where the is? That's going to be your equal sign. So we know equals 64. And we know sum means to add. So if we add the two numbers, we're supposed to get 64. So we can say x plus y equals 64. All right, now let's do the second equation. Okay, so for the second one, I'm going to read through it real quick. The smaller number is 6 less than the larger. And I'm looking for that equal sign. So that's going to be where the word is located. Then I'm looking at how on the left side I have the smaller number, and I said the smaller number was x. So that's going to be x. Larger number is y, and it says 6 less than the larger number. So this is where you have to be careful because subtraction is important to get the order correct. If you have 6 less than something, you have to have the something first, and then you take 6 away from it. So 6 less than the larger number would be y minus 6. And then the smaller number would be on the other side. Okay. So there we've created our system. And then in another video, I'll go in and I'll solve that. So right now I'm just focusing on getting these set up. You can go on and pause the video and solve them. And then we'll do that. I'll do that in another video, and you can check and see if you got them correct. Okay. All right, so let's look at question number 2. At a basketball game, a vendor sold a combined total of 180 sodas and hot dogs. The number of sodas sold was 2 times the number of hot dogs sold. Find the number of sodas and the number of hot dogs sold. Usually I go read through real quick and pretty much go to the end to find out what it is I'm supposed to find. So I'm supposed to find the number of sodas and the number of hot dogs. So I'm going to let x be the number of sodas sold. And y be the number of hot dogs sold. Okay, so pretty much I look for what the question is at the end to determine what I should let the variables be. All right, so on this one, that first sentence here, a vendor sold a combined total of 180 sodas and hot dogs. I'm going to take that first sentence and create an equation out of it. I'll do that one in red. Okay, so I'm going to think about this. So the combined total, okay, so the total number of sodas and hot dogs is 180. You don't actually see the word is right there, but combined total makes me think I'm going to be adding, and that the combined total is supposed to turn out to be 180. So if I add up the number of sodas and the number of hot dogs, I should get 180. All right, now I'm going to do the second equation. Get the second equation from the second sentence. The number of sodas sold was 2 times the number of hot dogs sold. So here's a form of B. That's going to be my equal sign. Okay. All right, and then sodas. Sodas was X. 2 times the number of hot dogs. Hot dogs is Y. And so I need the number of sodas, which is X, to equal 2 times the number of hot dogs. 2 times the number of hot dogs would be 2Y. So do you see how you take a moment to get the gist of the problem? Be sure you do this part where you designate what you're letting the variables be. And then you take a moment to try to see how to get two equations. And a lot of times it'll be like this one was, where you'll have an equation for each sentence. Okay. All right, so I picked about 8 questions. I looked at the kind of problems you were going to get in your homework and on quizzes to make sure I covered all the different types that you would have. All right, now this one's a little different. Let's just read through it. At a movie theater, a couple buys 1 large popcorn and 2 small drinks for $12.50. Then you got another sentence that says a group of teenagers buys 2 large popcorn and 5 small drinks for $28.50. Find the cost of 1 large popcorn and the cost of 1 small drink. So I'm going to let X be. I'm going to let X be one of those. Cost of 1 large popcorn. So we're assuming that they were charged the same for the popcorn and the drinks. Okay. And then Y would be the cost of 1 small drink. Okay. All right. So what's going on here is the first sentence is one scenario. So they bought 1 popcorn and 2 drinks. So if they bought 1 popcorn and popcorn costs X dollars, then they would pay 1X would represent the cost. So if you take the number of popcorns times how much it costs for 1 popcorn. So like if they bought 2 popcorns, X is supposed to be how much those would cost. So you would do 2 times X. If they bought 3 popcorns, X is how much each one costs. You would do 3 times X. So that's why we do that. 1X would represent the cost of 1 popcorn. Okay, the drinks, the cost of the drinks is Y, and we bought 2 of them. Okay. And that wound up being a total of $12.50. Okay. And when you're writing it, I don't need to actually put the multiplication sign, but that's what I'm doing. 1 times X plus 2 times Y. All right, now when you look at the next scenario, we got a group that buys 2 popcorns. So they would cost 2 times what the cost of 1. Then they bought 5 drinks, and each drink was Y dollars. Okay, see the 5 drinks, the cost of that would be 5Y, and that wound up being $28.50. Okay, So there's our system. We'll use elimination or addition method later to solve that. Okay. All right, so let's see what number 4 looks like. Remember, we're just trying to get everything set up on this video. Okay, Trey the trainer has 2 solo workout plans that he offers his clients, plan A and B. Each client does either one or the other, not both. So on Monday, he had 5 clients who did plan A and 6 who did plan B. On Tuesday, there were 2 who did plan A and 2 who did plan B. Trey trained his Monday clients for a total of 7 hours and his Tuesday clients for a total of 3. How long does each of the workout plans last? That's the question that kind of tells me what my setup for my variables is. So let X be, so X is going to be the length of workout A. Okay, and Y is going to be the length of workout B. Now it looks like he did both A and B type clients on each day, right? So we're going to look, one equation deals with Monday, so that's that first sentence, right? And then one equation deals with Tuesday. So here's the Monday sentence, okay? So 5 did plan A. So if he had 5 that did plan A and he spent X minutes with them, I'll say X hours, since things are in hours, I'll say in hours. So we don't have to do conversions. Okay, so 5 clients did plan A, he spent X hours with them. X was the length of time for each workout A. So 5X would be the total time spent with his A clients. Then we have the time he spent with his B clients. There were 6 of them, and we don't know the length, but it'll be some number of hours. And that'll wind up equaling the total time he spent on Monday. All right. And so we get that actually here. They trained his Monday client. Monday clients were 7 hours. So that should equal 7. Okay. Now I'm going to read through. Okay. On Tuesday, so now we're doing this one. On Tuesday, there were 2 clients who did plan A and 2 who did plan B. So he would have done those 2 clients for X amount of time each. So 2X represents the total time with the A clients. 2 clients did plan B. Y was the length of a plan B workout. So 2Y is the total time spent with plan B. And on Tuesday, he just worked for 3 hours. Okay, and that's because I got that right here. Tuesday was 3 hours. All right, so there's our system. And then all we got to do from there is solve it. Okay. All right. Now, I'm going to do a couple problems dealing with interest rates. And then at the end, I'm going to do a couple problems dealing with distance, rate, and time. Okay. All right. So first off, with this, the formula for simple interest is that the interest you would get paid or the interest you would owe, depending upon whether it's a bank account or whether it's a loan, can be found by taking P, which is the principal, the amount invested, R, which is the interest rate, and it should be as a decimal. So the R should be written as a decimal. And then the T, which is the time in years. Okay, so with simple interest, the interest earned over a period of time is not added back in. You don't earn interest on your interest. That would be compound interest. It would have a more complicated formula. Okay, so what we have here is somebody who has a total of $6,000 that they're going to deposit in 2 accounts. One account pays 3.5% interest, simple interest, and the other 2.5% simple interest. And then we're given that the total amount of the interest at the end of a year is $195. So that's right here. And then we want to find the amount she deposited in each account. That's the principal, is the amount that you deposited in each account. So that's what we're trying to find. That's what our variables are going to be. And I'm just using a chart to organize the information. But this, if I put an X here, that's like me saying, let X be the amount invested in the 3.5% account. I'm going to let Y be the amount invested in the 2.5% account. All right, so the rate would have to do with that 3.5%. Now, you may or may not know this, but if you take any percent can be changed to a decimal, it would equal percent, means divided by 100. If you take 3.5 and you divide by 100, you'll get 0.035. Okay, so the rate would be 0.035. The idea, what you do to convert from percent to decimal, since you're dividing by 100, it moves the decimal 2 places to the left. Okay, so we wind up with 2.5% would equal 0.025, and we put that right here. Okay. Now, it says at the end of 1 year, so we're only going to have the money in the account for 1 year. And then the formula says that your interest right here can be found by taking your principal times your rate times your time, right? That's what the formula says. So I ought to be able to multiply those. So that 0.35 times 1 times X would represent the interest that was earned in the 3.5% account. Similarly, 0.025 Y, would be the interest earned in the second account. Okay, let me write that Y the same way. All right, now here's the deal on this. I want you to think about this 6,000. That's the total amount that was deposited in the two accounts. I usually think of this like down here below the chart as my like totals area. And so 6,000 was the total amount deposited, and 195 over there was the total amount of interest, the total deposited, and then here the total amount of interest was 195. So interest is at the end, the total amount earned was 195. So here you're going to get one equation from this set, because it would be logical that since she's putting that money in just two investments, that the sum of the amount invested in each, when you add those up, you should get 6,000. And then the other equation is going to come from there, that the interest earned from the first account plus the interest earned from the second account should equal the total amount of interest earned. So this one deals with the principal. This one deals with the interest. Interest on one, interest on the other equals total interest. Amount deposited in one, amount deposited in the other should equal the total amount deposited. Okay? And then we'll go back and solve that in a little bit. All right, now that one was one where you're depositing money in a bank account and earning interest on it. I thought we'd do a similar thing, and this would be similar formula and all, but instead of it being money you're earning, it's money you owe. Okay, so she borrowed $34,000, 2 different loans in order to get a boat. One loan charged 5%, the other charged 7% simple interest. She winds up being charged $1,950 in interest after 1 year, and your job is to find out how much she borrowed at each rate. So this is what determines where you let your variables be. So we'll let X be how much she borrowed with the 5% loan, and Y how much she borrowed with the 7% loan. It was a 5% loan, so that would be 0.05 when you move the decimal 2 places to the left. 7% loan would be 0.07 when you move it 2 places to the left. Okay. It was owed after 1 year, so we'll put the 1 in. for each of those. Okay. All right, so then we'll wind up using the formula, x times 0.05, so 0.05x times 1, which would be 0.05x, would be the interest that she owes on the first loan, and 0.07y would be the interest she owes on the second loan. And then just like before, she borrowed a total of $34,000. So this is where I'm going to have my little totals area. So 34,000 all total, and she's charged 1,950 in interest. So that would be the total amount she winds up owing in interest. Okay. So just like on the other one, we're going to get one coming from the amount borrowed. X plus Y has to equal the 34,000, and one coming from the interest. So this equation relates the amount borrowed, and this equation deals with the interest on everything. Now we should discuss the reasonableness of taking out a loan for a fishing boat. Okay, I mean, if that's her livelihood, maybe it makes sense, but it seems kind of extravagant. All right, so we'll go back and solve that in the next video. All right, I got two more. This deals with a real common formula. Distance equals rate times time. You know this. You know, if you drive at 50 miles an hour for 3 hours, you will have gone 150 miles. Okay? So if you go 50 miles per hour for 3 hours, that'll wind up being 150 miles. You use it in a number of ways. For instance, if you're planning to take a trip that's 200 miles and you think you can average 50 miles an hour, that would be the R. You could find out how long it takes you. You could estimate how long it would take you. So it looks like it would take you about 4 hours to make that trip. So you use this relationship a lot, whether or not you formally think about it as a formula. Okay. So these can be, just kind of interesting. You really have to just read and think about how it's set up. So here we have two cyclists. So I kind of like to draw it. I'm going to draw it down here below this. Let me see if I can put another space right here. Give myself a little more room. Maybe not. Maybe I can move that down just a tad. There we go. Okay. So I just want to think about it. So we've got a starting point. One cyclist goes this way. Other cyclist is going that way. Opposite directions means that type of thing. Okay. One cyclist is going 10 miles per hour faster than the other. And it looks like it says if the two cyclists are 52 miles apart after 2 hours, what is the rate of each cyclist? So when I'm thinking about that, it's like after 2 hours, we're going to stop and look at where they're at. So one cyclist is way out here, the other one is way over there, and that they're 52 miles apart would mean that would be 52, and they've gone for 2 hours. So the one who covers more ground would be the faster one. Okay, and this would be the slower one because they didn't cover as much, just because of my drawing. When I was drawing it. And we did that after 2 hours. That's how far they went in 2 hours. All right, so I just kind of was trying to read and understand. Sometimes drawing a picture helps me, so I wanted to share that. And it says, what is the rate of each cyclist? So that's what we don't know. That's what we're looking for. Okay, so why don't we let X be the rate of one of them and Y be the rate of the other? And I just decided to make one of them faster, the other one slower. Okay. All right, now for the time, we know they both rode for 2 hours because, they started at the same point and they rode in opposite directions. And then after 2 hours, we checked and they were 52 miles apart. So the time should be 2 for each of those. Okay. So we know that rate times time should equal distance. So the distance traveled by the one cyclist should be 2x. The distance traveled by the other cyclist should be 2y. 2 times their speed, right, would give you the distance that they traveled. All right, so now we have to go back and think about how to get sentences out of this. All right, so let me come back up here. See this sentence right here? One cyclist travels 10 miles per hour faster than the other one. Okay. All right, so when you're thinking about that, see if this makes sense to you. So if I take my slower cyclist and I add 10 miles per hour to the slower cyclist speed, that should equal the faster one. Okay? So one cyclist travels 10 miles per hour faster than the other one. So this would be the faster cyclist. That's X. And X, the X cyclist, goes 10 miles per hour faster than the other, which would be the slower one, would be the other then. And that's what I let Y stand for. And then I usually just test it to make sure I've got it straight. So if X is the faster one, that should turn out to be the larger. So if this person was going 5 miles per hour, then this one would wind up being 15 and be faster. So that makes sense. All right. Now, my other sentence is coming from the fact that the two cyclists are 52 miles apart after those 2 hours. So this is the distance the faster one traveled. Okay. This is the distance the slower one traveled. But look at that picture. So the 2x would represent the distance the slower one traveled. No, 2x would represent the faster one. Let me put it on the right spot. 2x is the faster one's distance. 2y is the slower one's distance. But notice that altogether that should wind up being 52. Okay. All right, so there's my system, and I'm ready to go on and solve it in the next video. All right, one more. Okay. All right, so let's think about this one. All right, it takes Joey 2 hours to travel 8 miles in his kayak downstream. So I'm thinking about this. I'm thinking about having a stream, okay? And let's say the current is flowing this way, okay? So if he puts his kayak in right here, okay, it's going to take him 2 hours to go 8 miles downstream. And then it says the return trip took 4 hours. So if the current's going this way, when he does his return trip, let me do the current in red. So this is the flowing of the water. It's like this. Then let me do blue for the downstream. So downstream, he goes this far, okay, and he does it in 2 hours. And then in black, let me do the return trip upstream against the current. It's the same distance, but it takes him longer because he's paddling against the current. So I don't know if you've ever been paddling on a river, but it is a lot harder when you're turning around and going against the current. Okay. All right. So our job is to find the speed of the kayak in still water and the speed of the current. So I'm going to let X be the speed in still water, how fast you could go if there were no current. So that's you paddling, just based on how fast you can paddle. And then Y is going to be the speed of the current. Now you might get a problem just like this that involves like an airplane going with the wind or against the wind. I don't know if you've ever flown, but sometimes you wind up getting somewhere a lot faster than expected because you have what they call a tailwind. So the plane is flying at a certain speed, but then the wind is pushing you in the direction you're trying to go, and so you wind up going even faster than expected. And then the reverse can happen too. You might be flying into the wind and that slows you down. So you might see a plane problem instead of a kayak problem. I like the kayak because you can imagine it being just a small creek. So you're not like going all over the place. It's like a straight line. Okay. All right. So this is the part I want you to really think about. So if you're going with the current, then you're being helped. The current is pushing you even faster. So the speed you can paddle gets increased by the speed of the current. So you're paddling fast and the water itself is flowing. So it'll be x plus y would be the rate that you're actually going downstream. And when you're going against the current, you're paddling, and we're assuming you can paddle at the same, like you're paddling at the same rate. But when you're going against the current is pushing against you, so it slows you down. Okay, so against will be the minus, with will be the plus. Okay. All right, now we know when he was going with the current, it took him 2 hours. When he was going against the current, it took him 4 hours. All right, we know rate times time equals distance. So 2 times x plus y could give us the distance he went downstream. 4 times x minus y should be the distance upstream. All right, then we got to think about how to get a couple of equations out of this. Okay, well, wasn't the distance the same? Like he went from one spot to there, and then he just turned around and came back. So each of those are going to be 8, aren't they? And that's actually going to be your 2 equations. 2 times x plus y would equal 8, and 2 times x, 4 times x minus y should also be 8. The distance was the same for both of those. Okay, so that'll give us the 2 equations, and then we'll wind up working on solving those in the next video. And when we do, we'll find out how fast the person was paddling, and then how fast the current was moving. Okay, so let me stop this and I'll post it, and then I'll come back and solve these in another video.